It has been a software mistake because of caching. It affected probably only us, but it's not quite clear, so maybe well, hopefully it only affects us and we will keep it this. We have a news sheet and it says the same thing that we collected earlier, so I think Iran, you know what you can challenge, but I will also give you the news sheet, obviously, right? Then you can check as well if that is still correct. And I asked who would like, in general, take care of this issue and decide what would happen. And the office and myself, whatever, decided that it should have been the Secretary General, which is Tim. Tim was fine, but he's not here this year. So we will probably move this up further the hierarchy and go straight up to the President, so Martin can take care of himself. And you can just talk to me later, and we can like meet up together or separate, and we can get all the jurors together, whatever, like basically whatever you prefer and what is reasonable. But for now, let's move on with the first stage. So everybody, please quiet down. And we will have, in the third stage, we will have Taiwan be the reporter, Iran be the opponent, and Pakistan be the reviewing. Sorry, you're complete, I just saw. So, yeah, let's head to business. So please start your clock, and Team Iran, you have 1 minute time to challenge Taiwan for a problem.
So, we challenge Taiwan to problem number 1.
Problem number 1 has been challenged. You have 1 minute time to do your acceptance. Alright, problem number 1 has been rejected. You have 1 minute time to challenge another problem.
So the second problem that we challenge you is problem number 3.
Now problem number 3, ring on the rock. Yeah, so problem number 3, ring on the rock has been challenged. You have 1 minute to either accept or reject. We're down to 1, 2, 3, 4, 5, 6, 7, so we still have a little bit to go. So we have 1 minute time to challenge another problem.
May I ask why are there 7 more?
Sorry. So there is 1, 2, 3, 4, 5, 6.
No problem.
3, 4, 5, 6, 7. What? Oh,
Yeah.
oh, because so of course, three-sided dice, we've seen that. Okay, now it's different.
You're aware of the regulations.
Sorry, say again?
You're aware of the regulations and you won't challenge 7.
No, we're... Yeah, but you won't challenge 7. Yeah, that's good. Alright, and the other thing which we have already seen is 10. But this one is already dominated. So now we're down to 1, 2, 3, 4, 5, 6. Sorry. You may
Yeah,
challenge.
so the next problem that we challenge is problem number 17.
This
No,
time,
17.
17, invisibility. As the challenge, we have 1 minute time to accept. Alright, you accept the challenge? Yes. Alright, 17 is
考虑的。Hey, Alex. Alex.
From Team Taiwan, and today I'm going to report this number 17, Invisibility. It takes a problem statement. Medicare lens can be used to distort light and make objects disappear. Investigate how changing the properties of the lens and the geometry of the object affect the extent to which the object can be detected. And in the observation, you can see that there is a horizontal object that is fading away, and there are horizontal objects that still remain. So my key question is going to be how we determine whether an object can be seen, and why does the object become invisible, and how does object Here's my outline. First, I will be introducing the definition of the invisibility, considering two critical conditions. That will be the observation of our setup and 3 stages of visibility. And for the explanation of this phenomenon, I will be explaining it in a qualitative way and do some preliminary experiment, and that will prove the quantitative theory. Then we move on to the analysis of an invisibility condition, including a vertical and horizontal gradient. And finally, it will be our investigation of the geometry of the object, which is the width of the object. So, definition of invisibility. And how do human eyes define if there is object or not? First, if there is a visible edge, you can see that there will be a clear object right there. So we analyze the Kelly-Robinson contrast sensitivity chart, and we find that the brightness gradient must be bigger than this. And in another condition, if there is no visible edge, human eyes can still go through random differences to distinguish the object from the background. So by analyzing it, we find that the brightness differences must be larger than 20, and which the unit is grayscale. So to be invisible, it needs to available to satisfy both conditions. Moving on to observation. First, this is our setup. We put our lenticular lens right here on a track where the lenticular lens can move. And we put the object right behind here and apply a light to point on it. And we use camera to film right here. Then, in order to see this phenomenon, when the lens is close to the object, there is a clear edge. And by analyzing the gradient of it, the part of it is larger than 6, which satisfy our definition of clear edge. And then, when the distance increases, the brightness gradient is hard to define there is clear edge. But furthermore, the brightness differences is large enough to distinguish from background. So we define this situation as party visible. Then moving on, when the distance becomes way farther, and there will be no clear edge, and the brightness differences is too low to distinguish from the background. So in this situation, the object will be totally invisible. Next, for the explanation of this. So this is our film of our lenticular lens. So basically, it's like a convex lens, but in one way. So we put, this is the geometry of that lens, and we put an object behind this and move it away. You can see when the object goes farther, the image narrows only horizontally. So by combining these lenses together as an array, it will be similar to our experiment lenses. So this is our lenses, and we put an object behind it. When we move it away, the vertical bars will become harder to observe, and the horizontal bars still remain. That's because the horizontal object, the width of the object is low enough to be seen. So this is why in this observation, the vertical object will disappear and the horizontal won't. But there is some kind of limitation of this lens. So doing this two image, when the the low array density of the lens, and this is high array density. And you can see that the image on the film image on the lens looks like it's discontinuous, and this looks more like it's continuous. That's because it will be multiple, it will be image on each lenses, and when the distance of each lenses becomes too big, you will literally see each image of object on the lens, which made it discontinuous. So we are going to focus on high array density lens. So take a look at this part of the image. You can see that basically it's a multiple image behind the object, behind the lens. So this basically is the magnificence of our image. So by considering the brightness of the object, we assume that when the image of each lens is very close and we view from far enough, the thin column of light looks like is equally similar to lens width, which looks like this. Which means when the thick of the image of the object column is thinner, the light will be dimmer. So furthermore, when the lens width is entirely covered with the image, it will be the itself. So to analyze our invisibility condition, so to fully analyze an image requires 3 components, which by analyzing the horizontal cross-section here, the brightness distribution can be transferred into brightness gradient, which can be used to define a clear edge. And for the vertical part, using the same method, we can get a gradient like this. And furthermore, for the horizontal part, we can also analyze the brightness differences to distinguish the object from the background. So moving on, we'll discuss about the vertical gradient first. By analyzing the cross-section here, the gradient decreases while the distance increases. That's because in each lens, the image of the object becomes thinner. So the brightness will decrease like this. And for different width of the object, this is the width of the object, the gradient will be even lower because the image on the lens is smaller. So comparing to our theory and our experiment, the gradient is higher than predicted. So I'm going to explain this arrow. So this is a close shot with our macro lens, and this is the normal image we get from our experiments, which the camera is situated far from the lens. You can see the possible reasons that make it blur. So this basically is the blur of this kind of image, and this have lower average brightness, and this have higher average brightness. So we find the relationship between theory and our normal image and close-up image. We find that the close-up image more fits with our theory considered, and the normal image is the image width is higher than predict. So in order to fix the problem, we fit our macro lens close-up image with our general experiment, and you can see that the deviation is significantly reduced. Moving on to the analysis of horizontal gradient, the cross-section up here looks like this, the brightness distribution. So in order to describe this phenomenon, this is our lenticular lens, and when the rays that pass through we assume that the rays that pass through the focal length, and if the rays that hit the object, that place will be bright, and combine the multiple rays, it will be the image of the object. So it will look like this. When the rays that didn't hit the object, it will be totally dark, which looks like this. And use this consideration to apply to our theory, and the theory line looks like this, where it drops abruptly. But this didn't fit with our experiment, so I'm going to explain it. In real condition, so we assume that it's parallel approximation where all the rays will focus on the focus point. But actually, according to Snell's law, it will need to be considered a lens aberration. And by tracking the lens from the middle to the out, the brightness is kind of decrease slowly. And the theory fits perfectly by considering the aberration like this. So then I will be showing the geometry of the object. So this is our phase graph of our width of object. You can see that the critical clear edge boundary increase because the differences of object imaging increase. And for the brightness differences increase, like here, because because the object imaging increase while the width of the object increase, and it will be linear. But there's some deviation right here, and maybe that is because that we fit our within image with our close-up image. You can see that still this part, the close-up images will be blurred while image is very small. So this may cause an unexpected fitting, which at the last, when the distance is very far, it may deviate a little bit from our experiment. And also by doing the vertical analysis of our image, it will be invisible part here and an invisible part here, where the intensity will, the critical line will be linear to when the distance increases. So here's the conclusion. This is how we determine whether an object can be seen. We measure the gradient and the brightness differences on the image, and we find that the brightness gradient need to be 6, and the brightness differences need to be this value, and the unit of it is grayscale. And next, in order to explain this phenomenon, we put our lens together and make it an array. So the image will strengthen horizontally, and the vertical bars will disappear like this. The disappear reason is that the image becomes very small and it's hard to observe, and the horizontal still remain because the width of the object is large enough, so the image of them will still be large, so the horizontal won't disappear. And we qualitated to calculate the brightness difference change, this, and the image, considering the aberration, the modified theory fits real well with our experiment. And this is, and we quantitatively predict every region of visibility, like here, and here's my presentation.
All right. We will have 2 minutes time for questions of the opposition.
Can you speak up a bit, please?
Thank you from the reporter. First of all, in what direction you put it? Horizontal or vertical?
The arrays on the lens is like this.
It's horizontal.
This is vertical.
It's vertical?
Yes, it's vertical.
Okay. And how did you put the object behind the vertical lens?
Extreme.
Can you just say the object is vertical?
This object is right here.
It's vertical.
Yes.
Okay. Thank you. And can you mention how does the size of the object that you have affect the phenomenon?
Do you mean like the width of the object here?
The dimensions of the object, yes.
Dimension? Yes. Width. Just
Yeah. How does it affect the phenomenon?
if the width of the object is larger, it will be more visible.
Like if you have a bigger object than the
Bigger.
lens that you're using,
Yes.
we still can see the invisibility.
No, it's just if the width of the object is very long, it's just like a horizontal object here.
Okay, thank
And
you.
it will not be visible.
How does the number of ridges on the lens, the electrical lens that you use affect the phenomenon?
Can you repeat again?
Number of the ridges.
Oh, you mean like the density of the
Yes, the
lens?
density
Oh,
of the
if
lens.
the density is like too low, you will basically just see multiple image on
But
each lens.
if we increase the number of the ridges, the invisibility will be more.
No, it will be the same because we also need to consider the focal length and the width of the
Okay,
yes.
thank you. We'll continue discussion. And can you start with where should we put the placement of the object?
Oh, behind the lens.
No, it has to be like in which closer. Is there a limit of the placement?
Yes, where this.
Okay, thank you.
All right, thank you very much. Time for questions is over. We have 3 minutes time for final breaks. second step. Alright then, that's perfect. Please start the presentation in 4 minutes.
Okay, problems I have received appear to be the premise of question number 17. Problem states that dimensional lenses can be used to distort the light and make objects disappear. Investigate changing the properties of the lens and the geometry of the object and the effect to the axis which the object can be detected. So the main investigation would be the object, that the placement of the object, the size and dimensions of the object, and the lenses that we're using here. So just to start this overview, that we're going to say that there are basically were solved two conditions that introduce the lenses and how does the invisibility works in this phenomenon. The two conditions were the visible edge and the brightness distortion and the critical points based on the problem purposes that I mentioned in the previous slide. And the main investigations and parameters were mentioned. That would be the distance and the clear edge of the electrical lenses that he used. Although I think that he could mention the intuitive view of the electrical lenses that he used and how does the ridges and the dimensions of the ridges work here. But we'll talk about in discussion. And he had experimental setup. He introduced the experimental setup that he had for this phenomenon. And he also had the qualitative theory based on the change of the distance from the object and the electrical lenses that he used. Other than that, I think the placement of the object would be the smooth part of the electrical lens or the rich part of the electrical lens can affect the phenomenon. And we will continue that discussion. And also, he did mention the relation between the brightness and the lens's position on the qualitative theory and the different placement of the setup that he did change the electrical lens that he used and did change the distance between the stable placement for the object, but he did change the placement of the electrical lens and the brightness average was analyzed and the data comparison. And now for the reporter's evaluation, starting with the strong points, he had various densities for the lenses that he mentioned how does the density of the ridges will affect the phenomenon. And he used the right shape of the edge, the half cylindrical shape he mentioned, and the different kinds of the gradient dimensions of the object. And also he did mention the detailed charts on the various parameters based on the theory that he had. Also for the areas of improvement, I can say suitable height of the lens can be also mentioned. Also the lack of analyze on the background, that the placement of the object behind the smooth part or the rich part of the electrical lens, and did not clarify the reasoning behind the light reflection. That's in my opinion. And the object's placement was not right, that we will continue the reason in discussion. And I think he did not investigate other ways of lenses placement or change the number of the lenses. He could use like 2-layer for the lenses and you see that how could it affect the phenomenon. And also he used different types of the ridge for the lenses, like I think the lenses that he used in the observation of the phenomenon was a half cylindrical. He could mention other kind of shapes for the ridges. And now we'll continue the questions and discussion.
Alright, thank you very much. We will move on to the discussion. We will pause the clock real quick to turn the presentation up if you want. Yeah, can you pause the clock real quick? Reset it, okay, that's fine. Yeah, I mean, you want this presentation, right?
Yes.
Yeah, then let's just wait until it's done.
Okay.
At least try to get it up.
Yes.
All right.
distance between the lens and the object?
Do you mean like this line, the clear, it will be invisible, totally invisible at this?
This is the distance from 45. You investigate the phenomenon till the 45 centimeter
Yes.
from the object, right?
Yes.
And the object is stable. You just change the placement of the lens.
Yes.
So, don't you think that what will happen if we continue this distance after 45
Oh,
centimeter?
the brightness of the object will still decrease and it will blur a little bit because maybe kind of out of focus. So yes.
Don't you think that it will affect the reflection of the object?
No, the reflection will be even smaller when the lens is really close to the camera because the light only points to here, so the reflection on the lens will be even smaller.
So, okay, I agree with that, but I think we can say it like this, that if we increase the distance, they will decrease the light reflection, and the phenomenon will not be happening, and it will not have the invisibility, we just won't see the object. Are you agree with that?
Do you mean that when the distance is very, very, very far, it will be totally invisible? Is this what you want to say?
Yes. Okay.
Yes, so I agree.
Okay, thank you. And you talked about the partly visible part on your diagram.
Yes. So partly visible will be this. So because at this partly visible, you can't tell if whether it's empty or not, but the brightness difference is still large enough to distinguish the object from the background, but the presenter is kind of sorry.
So, but partly visible, like how did you manage to investigate the meaning of partly visible?
So in our report, I have mentioned that if the human eye can't tell if there is visible edge, human can still through like
You can see a very
Like-
clear shape.
yes, it's like some like a marble or Lego bottom at the map. You can see like there's object, but you can't tell what
it's not clear, but it's not that much invisible.
Yes. So yes, you can still know that there's object there.
Yes, I understand and I agree. Thank you. And can you bring slide 13? Okay. I didn't really understand the schematic version that you mentioned here. Can you?
So in this quantitative explanation, we can see. This is the geometry of
This
this.
is part of the ridge, right? Like
Yes.
just one ridge and not the fully one.
The green volley is like volley is like many of this, or volley is the whole land.
Yeah, it's just part of this little.
Oh, because yes, it's a part of
Okay.
the it will be all same.
Mention one more time.
How this works?
Yeah.
Yes.
Go
So
on.
of this geometry, it looks like a half convex lens, right?
Yes.
It's convex lens, but only like the geometry will make this only narrow and horizontally. It will not narrow this way because this doesn't have truth right here. So the object will like narrow horizontally, and this too it will narrow horizontally. But when there's multiple lens at here and all of them narrows horizontally,
So
it looks like
the blue
this
section
geometry.
is representing the object, and what you have behind the green section is the
Yes,
background.
yes, the horizontal.
So
The object, these two are all objects.
So shouldn't the lens that you're using be like in the 90 degrees to like closer to the object that you have, or just have to be against each other, like vertical on vertical?
Do you mean like rotate the lens?
Shouldn't the object be horizontal?
Shouldn't the object be horizontal? Yeah. So it looks the horizontal one is just like the width of the.
No, not the background, just the object that you want.
This could also be the object too. This could also be the object, but a very large width of the object.
Oh, so you're
Yes.
saying that if we rotate the object, it will give us the same invisibility that we have
As
right
you can
now.
see, this is a very cool object right here, right? When
Yes.
you increase, it's like it's going invisible, and for when the object is horizontal, it does not.
Okay, so the lens that you're having right now, in what direction is the ridges that you have on the
Oh,
did you
it's the
see
same.
it? It's like this.
Yes,
And
I
how did you
you
manage
just
to have it view?
like scrub it on it, you can tell.
Okay, thank you. And okay, and can you tell me that how does the object shape? Like, do you agree that if the object that you have behind the lens is
Yes.
bigger than the size of the lens, they don't give us the same invisibility of the smaller object?
So if doing the object is way bigger
Way
than
bigger
this,
than the lens.
yeah, then this will basically just be like there's a very big width of the object there, and it will not be disappeared because at this narrow horizontally.
There is a limit of the dimensions of the object. Do you agree with that or not?
Yes, I agree. There will be a limit of it, and it can affect the extent
That
that
should be hide behind the lens that you're having.
do you hide behind the lenses behind. What do you mean like hide?
Like, it should be smaller than the lens that you have, or in the same size.
The object width doesn't matter. It's the what? Yes,
Okay,
the
thank
object.
you. I don't think just use the word I wanted, but okay. I hardly agree. And if you remember the slide that you showed how does the reflection of the object change on the ridges that you have on the
Reflection. Do you mean like aberration?
The slide 23, I think that was slide 23. Yes, right here. So the object that you have is here or here?
Object? Oh, this is the object, and this is
So,
this.
well, don't you think the placement of object should be behind the smooth part of the object?
No, as long as this lens all have same focal length at when the angle is very
Look,
small angle.
you introduced your schematic version of the object and a background behind it. We can see both reflections, right?
What do you mean reflection?
There is a light reflection from the object and the background that you have, right?
Just image. Okay. Yes.
Okay, and when you place the object in front of the ridges,
You mean like put the object like here?
yes, well, I
so,
think
yes.
to investigate this phenomenon and see the invisibility happening, we should put the object in the
No, it's still saying because like when the rays like pass through this kind of groove, the rays will like kind of change direction. Yes.
Okay, so
So it's saying if you put object here or here.
yes, what I'm saying is that this is a electrical lens that we have, right?
Yes.
This is the lens.
Yes.
Okay, so we put the object here, and then there is this background, right? We have a reflection from the background and the object.
Oh yes. So that is considered in our language. The A right here represent the background brightness. Yes. So we try to control our background as dim as possible as we could, where the A is approximately like 5 grayscale.
Look, what I'm saying is that when you look from the original, this is the observer here, right?
Yes.
So when the observer looks from the original part, which part you should see? The background, right? You agree that the background is
The
where you
whole,
see.
yes, the
Because
whole
we
thing.
want to make
You will
the
see the
object
whole.
invisible.
You will see the like whole
Yes.
thing right here.
Yes. So by the reflection that we have here, can you show me that how does the reflection of the background and the object change if we have this kind of system behind the
This,
smooth part?
this.
Okay, so I disagree because I think it would be like vertical and then when they reach this the
Oh, I
ridge
mean,
part.
because this is the camera or what you mean is the observer, right? You will observe the ray that you can. If you like a view from this angle, and you can see. Oh, sorry. You can see the things right here. You can
But
see
what I'm
them.
mainly saying here is that the right placement of the object should be behind the smooth part, not the original.
Yeah, it's all same. Although it.
Alright, sorry, time is running out. This 1 minute time to summarize the discussion.
Okay, so basically that I mentioned the main part of the investigation would be on how is the reflection works in this phenomenon that I think by the presentation that he had, he did put the object right on the rich part. But what I think is that if this is our dimensional lens, what we're having here is that there is an observer here, right, above the rich part, and then there's this body that we're going to make it invisible, and a background behind it, which the vectors from the reflection should be like this, and when they reach the smooth part, they will turn something like this, right? And there will be a point that's like quick, and then after that, when they want to see the reflection, there will be the lights going away from each other, which that's why we see the invisibility phenomenon. So that's basically
All right. Thank you very much for the summary. And now we will have 3 minutes time for the questions of the group.
Can you take the presentation? Yeah. Meanwhile, there's a question from the opposition. Do you believe that that dimensions of the object, for example, if it's an irregular object or not, do they affect the extent of invisibility?
yes, I do believe the effect invisibility.
To the reporter's side, do you think that you investigated various
Yes, as this picture did show, when the width of the object increased, it affects the visibility.
Was this width uniformly increased in the sense that was it a regular cylinder or an object with a
Can you repeat it?
Right. So moving on, can you move to slide number 9? So in this animation, this lenticular lens is being shifted, right? Don't you think that two parameters are being changed at once? The distance between the lens and the object, and the distance between the
Yes,
lens and the observer.
I agree, yes, but
Do you think that's important for analysis? That's not right.
no, that's not correct.
Thank you. Can you move to slide number 20? Slide 23.
23.
Yes. So this is both for the opposition and the reporter side. If this lens was flipped, do you think the phenomenon would still occur?
By
If the lentitudes face the other side.
flip, you mean you put the body here in the smooth part?
Yes, the observer goes here, the object goes on this.
Yes, that's exactly what I said. The main investigation should be like this and not like that, because it's the smooth part that will
Do
be.
you think the phenomena will occur or not?
Yes.
Do you think the phenomena will occur or not?
Yes, it will still happen. Considering the snail star, yes.
Where from the opposite side, what would happen if the height of those individual lentitudes were this semicircular cross section? If the height was increased, or we can call it the radius as well.
But you mean the density of the?
No, not the densities, the height of individual lentitudes.
You mean that this is like really long?
Short, I think the word.
Yes, so for the reporter right here, say, there will just be no vertical. You cannot define the object from vertical direction. You can only define object from horizontal direction.
Right, and lastly, from the reporter side, do you think the background color will affect the extent of invisibility?
Yes, it will.
Did you investigate changing the background color?
So, yes, so when during the color, it will affect that the brightness of the comparison between the object and the background.
All right, thank you very much. You have 2 minutes time for final preparations of the briefing.
demonstrable problem, how it is fulfilled by what's inside. So number one, how technical lens is that, right? Qualitative analysis was done by the reporter. What exactly is that invisibility, as in quote unquote the extent of invisibility, that was also explained by the report in a qualitative manner. How different geometries of the object affect invisibility, not done by the report, but and it was in some capacity pointed out in the opposition. The major part that was missed was what would happen if it is an irregular object, in the sense that the part with the larger radius can also come and interfere with the lens at a lower rate. The rays can come from everywhere, and that can also impact the invisibility in the large area. Moving on, how does diffraction make objects clear? For the reporter, and providing mathematical models to test the extent of invisibility and some questions by the reporter, incorporating contrast with background was also was complete. So I'll move on to that part in a while. The process of this. So what were the merits of this? A correct description of how the light of how the lenticle lens diffracts different areas of light, more longer than experimental design as well. Average brightness to analyze the software and data points were also properly designed. What were the possibilities? They did not investigate how the distance between the object and the lens extend visibility in the sense that they were changing two parameters at once, and they assumed that one parameter would not affect without giving us the proper experimentation why that wouldn't affect the invisibility. The invisibility to begin with, we believe it won't affect it, but reasons behind that were questioned, as in the distance between the observer and the lens, because they were changing both of them at once. The problem demands a phenomenon to be investigated on both sides. The lenticle lens is having flares as well, so we have to be able to operate on that side. Color of background is completely ignored, which is an essential part of this presentation, because the contrast, just by their own terms, defining the edges of the image can only be done when the background color is also incorporated in some capacity or the other in the mathematical model and in the experimentation. So I'm not talking about the relative brightness, I'm talking about the proper edge and the exact color. And they also exclusively use cylindrical rods during the experimentation, and objects are not limited to cylindrical rods. Irregular objects as well. There was limitation. What were the merits of the opposition? They correctly point out the multiple limitations of the traffic experiment. They point out the flipping and point part of this experiment. But again, it is directly established that I've discussed later, including the most important one, which was the contrast between the background and the object. And the discussion was more questionable than the conclusion, which was so what were the missed physics and from both sides? There were no different geometries of object that were investigated as defined by the problem, and maybe this should have been essential part. The conclusion is what happened with the lens is flipped, the conversation does not specify the side of face the object, so both of them should have been done. And the contrast background is an important factor of calculating the extent. Now moving on to discussion analysis, the opposition said the first point, what will happen to the distance between the lens and the object? They showed us a graph with the relevant parameter, but the data was not relevant as to parameter protein change. Because we agree with the report on that part, the distance between the observer and the lens does not matter, but we needed something to prove. The clarification on geometry decided to give a correct explanation. And the point, what we find in it was an irrelevant question, and the point was already clear and was described well in the report presentation framework. The changing opposite point of changing the sign in lens of lens in which should be smaller than the lens. They describe changing the lens in the right direction of sensitivity, and they give the report to that point that the lens does not need to be bigger than not this kind of phenomenon is still after. And I mean this is already discussed before the last game.
All right, thank you very much for this. We will have 2 minutes time of concluding remarks from the reporter.
Okay. So when the distance between the lens and the object is large, the object will still be invisible, predict with our theory, not because lens reflection of the lens. And also, there is a limitation toward the size of the object to achieve, which is to achieve invisibility. Increasing the object size is same to increasing the thickness of the object. So further on, the intensity measurements are of course related to the background, where the background brightness could affect the gradient of the object you see. When the object brightness the background brightness increases, the gradient will decrease because the comparison of the brightness of the object and the background becomes more similar. And also, as seen here, the invisibility occurs saying both when the object is behind the smooth and bumpy part, like this. It still becomes invisible when you flip this right here. The invisibility situation still occurs, and this can also be expressed by different shapes. But cylinders are best to illustrate this phenomenon. And thank you.
All right, thank you. And then we will have 5 minutes of theory questions, and then you can put on the presentation again. Do we have any answers on already yet? Perfect. Then we'll start with Sam, who already had his hand up.
So, two short questions. How do you measure the geometry of your lenticular lens?
We film it with camera very, very closely, right? The lens on this is very small.
From the side or from above?
From the side.
Okay, thank you. And then you focus quite a lot on the vertical analysis, the vertical gradient. What relevance does this have to this problem?
I do both on horizontal and vertical.
What's the relevance of the analysis, the vertical gradient in this problem? You can answer if you wish.
Okay. So some part of the object may not be fully covered by the lens. So you want to see if the lens doesn't cover the entirety of the object, there might be contrast. So we just want to compare what happens if there's a lens and there's no lens.
Okay, thank you.
All right, that's it. And maybe while we're on the topic, I will throw in a question. And if you go to page 25, and then the right graph, please. This was not the correct slide. You have one where the vertical part is invisible, which maybe comes a little bit higher as well. So, do I understand this correctly that even vertical objects at a certain distance become invisible in your case?
Vertical analysis basically means the object is situated like there is object here and there's no object here. So
okay,
you got that gradient here.
If it would be okay, now I thank you. Thank you. Yeah, please. No, yes,
On the report, do you think it will be good if you use two layers of the lenses, one horizontal and one vertical next to each other?
Do you mean lens right here and another lens? I think it will the light will be distorted 2 times, so the invisibility condition will be not.
Did you understand? Then you can repeat maybe the answer.
Can you say just what Yeah.
So although we didn't actually have the data for this, but it will be more invisible because it's compressed, in 2 different directions. So if you use ray tracing and you analyze the brightness, it will be more thin. Yeah, so it will be more invisible.
Then we will have Don ask the question.
I would like to direct my same question first to the reporter and then to the reviewer. If you were to use a substance with a higher refractive index,
Yes.
would it affect the distance where it becomes invisible?
Yes.
How so?
How so? If the reflection index is
Increase or decrease the distance?
Okay, that is a good answer.
And your answer?
Decrease. Yeah, the distance will decrease when between the object and between the object and the lens, and it will become more.
yes, same thing.
Alright. Do we have any other questions?
Yeah, I have one.
Justin, please.
How do you think the effect will change if you take the lens?
So tilting it like this.
Yeah.
It's certain angles.
Okay. So we put the object on behind the smooth part.
No, I'm just saying if you take the lens by an angle.
When you put as long as the vectors that we have for reflection won't change, it will change the phenomenon.
Alright, thank you. We will have another question from Sam.
So, to the reviewer, you are sure that if you have the object must be behind a ridge for it to be invisible.
Asking
Yes.
And yes, if you put the object behind the smooth part, you will have the phenomenon happening.
And just to make sure she was here for
Sorry, opponent, yes. Opponent.
Can I also add something?
You can add something because the
Yeah. So basically, in his own chart, we had the object here, but the light that was showing was brought from bottom to up. So basically, the light should be shown from the object toward, like passing through the lens toward where we see, like the observer is here, the lens is here, the object is there. But what we saw in the diagram was totally inverse.
All right, thank you very much. We are unfortunately out of time for any other questions, so we move on to the grading, and you of course can sit down if you may. grading. We will do the report first, of course. From Taiwan, we have the grades 6, 9, 7, 8, and 6. And then we have the opponent. We have a 6, a 7, a 5, a 7, and a 4. And we have the reviewer, we had a 6, a 7, a 5, a 7, and a 7. Alright. Yeah. Yeah. Alright, we will try to keep the feedback a little bit shorter because we are running out of time for the people to have a little bit of Alright then, first. Is there any, do you have to leave already? No. And, alright, for the report. So maybe I can comment quickly on line 6. So first of all, this is for consistency. Well, I've seen another invisibility report which was slightly better. I gave it a 7, so I need to be consistent with that. I think we have a little bit of a rough time explaining your theoretical model, how this then results to your actual theoretical curves. And then you even had to correct them multiple times until they fit the experiments, and the correction you have given were unfortunately not very well physically explained. So, I mean, for example, I did not understand, but unfortunately I didn't get around to ask the question whether whether the fit you did to correct for the experiment, whether this was an independent experiment or whether you fitted your theory to the actual experiment and then it fitted the experiment. So this was something you definitely should have been more clear about. And you didn't do any color variation, you didn't do any geometry variation, no rotations. Yeah, stuff like that. So a few points were missing in this slide. And then of course we have on the other hand the positive eyes we have not.
So I thought it was absolutely superb. I have seen this problem earlier in the tournament, and based on consistency, I thought this was better. It's always open to always do more. I think the quality of the process and the results is superb.
Alright. Sorry, our partials, mine was 1 before, 2.752, and yours?
5.5, 2.5.
Alright, thank you very much. And then we have the opposition, the lowest grade over 5 from Sam. Sorry, the lowest one was 4 from Ken.
Yes, what the thing I disliked most was the thing that you stuck so much on the flipping discussion, because I don't think it's so relevant, because it doesn't matter that much. Maybe it has I don't know, minor relevance, but not the basic physics behind is not affected by that. So that was the main reason why I did it down here. All the others was okay.
Alright, and then we have 2 7s, so maybe Jesse can comment on 7.
So my partials are 1, 2.5, and 2, and then I rounded up to 7. I like the fact that you were thinking about clarification in the fixation phase, and then you mentioned 2 points of maximum and minimum distance.
Alright, thank you very much. Do you want to
add the main lacking in this one was the investigate any other geometries of the lens, which is specifically stated in the point formulation, and you should have questioned more on that.
And then Sam, you can continue with the 5 for the review.
Again, so what makes a strong review for me is where you ask questions which the focus missed out on. You should have asked more clarification questions on the geometry. Also, you focused also on the background color, which I think was less relevant to the problem than the lenses. So you did too much focus on the background color contrast.
Yeah, and then Michael, maybe you can comment on your partials you did not.
1, 1, 1, 1, 5, and then round it up.
Alright, and then we have a few 7s, so maybe Michael, you can comment on the 7 for the review.
Yeah, okay, I liked that you found some missing points concerning the object. So, because the object was rarely investigated each other before, and that was stated in the problem statement, so that was a good point. And overall, I found it quite good review. So, it was 1.5